Hi, my name is Dr. Ambikesh Jayal, and I have created this tutorial for simple classification modeling. The dataset that we'll be using in this tutorial is Boston housing dataset available from this link. Link has been included in the tutorial. And as you can see, this dataset originally contained 14 um, variables, and all of them are continuous variables, so they are numbers, as in these. And what I did was, because I wanted to use this dataset for a classification task, so I have included a category, a categorical variable investment risk, and which is this highlighted in blue. And the task is to create a model which will take as input the columns in yellow and give an output as to the investment risk. So for example, if I give it this second row as the input to the model should be able to predict investment risk category highlighted in red. Okay, so, and I have given you some other useful links. So the most important one is the Pandas cheat sheet, which is here, and it's quite handy. And as you can see, the data frame is basically an Excel sheet. So it has got column names, row names, and the data. The regression task and classification task are very similar if you are using RandomForestClassifier. So out of these steps, so step number 1 till 5 are exactly same as you do in a regression model. And so I'll just quickly go through it. So this task 1 is basically reading the data into a data frame, DF. And here line number 12, 13, we're just printing the data frame. As you can see, it's the column names and the data. Here we are just printing, more information about the data frame. Here we are just checking if there is any null value in the data frame, and if there is null value, then we are dropping. Also, we're deleting the rows which have any null value. Here we are just getting the basic stats for each variable. So, mean, standard deviation, max, median, and all that. And then we are plotting some graphs, so like box plot and histogram. Out here, we are just creating a correlation matrix, which tells you how strongly two variables are related. And we are drawing a heat map. And as you can see in this correlation matrix, if you just hover over this function, it will tell you the details about the function. So the methods that we have used is Pearson coefficient. There are other options available like Spearman. As you can see here, for this value, so there's 0.89. So the correlation is the value is between -1 and 1. And if it's -1, that means two variables are strongly related and they are negatively correlated, which means if one increases, the other decreases, and vice versa. If two variables have the value near 1, that means they are strongly correlated, which means if one increases, the other increases as well. So you can see the correlation coefficient between RAD and CRIM is 0.89, which is very high, which means if RAD increases, then CRIM increases as well. And it has been highlighted in blue because it's showing it as a heat map. Similarly, the value here, which is the correlation value between MDev and LSTAT, is -0.7. So it's a high number, but it's a negative number, which means the MDev and LSTAT are negatively correlated, which means if LSTAT increases, MDev decreases. And that's why here in heat map it's highlighted in red, which is closer to -1. Here, the feature selection, it's exactly same as regression. The only thing is For the target variable, we are selecting investment risk. In the regression task, we would have selected a continuous variable such as MDev. In categorical variable, we are just selecting the target variable as investment risk, which is a categorical variable. And rest is same. We are then converting it to a NumPy array because NumPy array makes everything very fast. Here we are splitting it into training and testing data sets. So this line number 3 splits the data into 80% into training and 20% into the testing. And the rationale is that the training data set will be used to train the model. And in order to test the model, we will use the testing data set, which the model hasn't seen before. Here, in the next step, we in the regression, we would have used RandomForestRegressor. Because it's a classification task, we use the random classifier. And the random classifier, the details of random classifier can be accessed using this link. And I'd recommend you go through this link because it tells you all the different parameters. So for example, n estimators is the number of trees in the forest. And basically, the way a random forest works is it creates many decision trees. And then the average value from the decision tree is from multiple decision tree is the predicted value. And so we have put in here n tree equals 5, which means we want to create 5 decision trees. There are other variables as well. So for example, maximum depth. So what would be the maximum depth of the tree? Don't give this number as too high, because otherwise it would be, if you give it too high, then it would be lead to overfitting. If it's very less, then it would be underfitting. So you need to find the right value for this. And you could do hyperparameter tuning to find the optimal value. So we use a random classifier, and then on line number 13 we train the model. And once line number 13 is executed, we have got the model dt_model. And in the line number 15 to 19, what I'm doing is I'm predicting the values for the first 10 rows in the training set. And these are the predicted values. So the predicted values for the first one is medium, the true values are medium, and the predicted are medium as well. And then it is making one error. I think the second last one, the true value is low, but the predicted value is medium. So accuracy score is quite high because it's just made one error. Whereas in training one, when I'm trying to find the the testing data set, then it has made 2 errors. And where are the errors here? So the first one is medium, but it's predicting it as low. All right. And the first, second, third, fourth, and the fourth one is high, but it's predicting it as medium. So it has done 2 errors. Now we can plot the confusion matrix. And this is the code to plot the confusion matrix. So first is the confusion matrix for the training set, and the second is a confusion matrix for testing set. And basically what confusion matrix does is these are the true values and these are the predicted values. So this is the confusion matrix for training dataset. And as you can see, there were 59 cases wherein actually it was high and the model predicted it as high. So which is model predicted it correctly. So along the diagonal are the correct predictions. 113 cases were low. Actually, they were truly low, and model predicted them as low as well, which is good. 154 cases were actually categorized as medium. They were truly medium, and the model predicted them as medium, which is good. The other values are the errors. So for example, this one here, so actually it was medium, but the model predicted it as high. So that's an error. This number 6 is an error as well, because actually it was high, but the model predicted it as medium. And so that's your training set. On the testing, you can see the error has increased. So 16, 22, 34, they are the correct prediction because they were high. 16 was high and the model predicted it as high, so which is right. But this number 10, which means actually 10 cases were actually truly they were medium, but the model predicted them as low. So this 10 is an error. This 3 is an error, and this 6 is an error as well, because this 6 is an error because actually they were low, but model predicted them as medium. So the total error is 10 plus 6 plus 3, which is 19, and the total error in the training set is 12, 14, and 15. So you can see that the error in testing is higher. And if I wanted to plot the confusion matrix with percentage, this is, what you do is you just normalize equals all, which means it will give the value as normalized between 0 and 1. And this is for the training one, and this is for the testing one, and you can see there's 11% error here. There is in the training set there was 0.005% error for this column, but for the testing one it's 0.11, so quite high error. Okay, if we wanted to measure the accuracy of the model, we can do it something like this. So accuracy score, and if you just hover over it, then it will tell you the more details about the function. Basically it just calculates how much accuracy is there in the model. So values that it has correctly predicted, what's the percentage of the values that it has correctly predicted. So I use that function, and then I print the training accuracy and I print the testing accuracy, and as you can see, the training accuracy is almost 95%, but the testing accuracy is 0.79%. So that means model, as expected, has performed quite bad in testing scenario, in the testing data set. And this code, you can generate the dot file, and if you generate the dot file, then you can visualize these files in the graph viz. Let me just quickly show you here. Yeah, so this is the graph viz wherein you can visualize your files, something like this. So you paste the code of the dot file here, and it will show you the corresponding graph file, corresponding decision tree. Okay, so what I'm going to do is I'm quickly going to, so this is the 5, because you can see 5 files here. Why? Because in the classification model, random classifier, we gave it a parameter as 5, so that's why I generated 5 trees. So I just download the first tree, and what I'll do is so this is the tree 0, decision tree 0. This is how it looks, and if you want to visualize it, you can copy and paste and go to the this GraphViz site. I just paste it here, press enter, wait for a second, and then it will generate this decision tree. So I'm just going to visualize this decision tree. So this is our first decision tree, and as you can see, this decision tree starts with LSTAT. If LSTAT is less than 14.4, then it goes to this node, otherwise it goes to this node. And the details about this Gini score, the number of samples is in the first node there are 208 samples. Why there is 208? Because in the random classifier we have given it as max samples 300. So although in the total data set, how many samples are there in the total data sets? I think in training versus testing there's 80, 20, so probably 400. But What it does is it doesn't include all the samples in while creating the model. It only includes a smaller subset of the sample for creating the first decision tree, then a different subset for creating the second decision tree. So it makes sure that all the decision tree are different from each other. And um, yeah, so it generates a decision tree, and using this, it predicts the values. More details about the decision tree have been covered in the previous lecture. Okay, so that's how you generate the decision tree, and that's how you generate the confusion matrix. What you can do is try to change these parameters and see what the effect would be. So suppose if I change the depth to, let's say, 12, and let's say features to 7, let's see if what the effect it will have on the accuracy. So I run the model, and then I run the model here, the confusion matrix, and what I'll do, I quickly run the final score one, which is this one. So right now it's 95.79. If I run it now with the new model, it's 98.74. So you can see that the accuracy of training data set has increased, but the accuracy of testing it has decreased, right? So testing accuracy is the real accuracy of the model. Okay, so thanks very much. And the code for this tutorial is available here. And yeah, thank you very much.